Okay, so here you have the idea of living force was a theory of Gottfried Leibniz that there is a creative force. It's going to basically say that there, and if you type in living force in physics or living force physics in YouTube, there's absolutely no information. I mean, there is just barely any information on it, like videos with barely any views. There's one a fairly popular YouTuber that I was going to get into, like Physics with Dan or something, and it has 80,000 views. Um, so, and this idea seems to kind of sum up the kind of sum up what exactly happened to living force and how it was never really um, surfaced. Like it's never really surfaced in the physics conversation. However, it does seem to be the first uh, perpetually metaphysical argument and also not only quantum mechanical argument. Just the idea of living force, Gottfried Leibniz, was that there was a creative force. The theory was eventually absorbed into the modern theory of energy. All right, so I've argued that energy was somehow, well, Einstein's energy was somehow different than Leibniz's kinetic energy because I thought kinetic energy was more dealing with dark matter proponents and energy. Einstein's energy was dealing more with this creative force thing. Now, never would I imagine that they would be sort of in the same category just because um, I imagine that Einstein's energy was more of a reverberation of Newton's force in that it had uh, it was just adding another component, like maybe a third dimension. Excuse me, like maybe Newton's force, forces of gravity, and things like that. It was just sort of background. Energy was just sort of background to Newton's force. Obviously, if you add this extra dimension of space ever expanding and things like that, it becomes very dangerous and very quantum. You know, just Newton being known more as a physicist and Einstein being known more as a cosmologist in that perception. Well, a cosmologist and a mathematician. Um, in the idea that Newton was sort of the father of physics. Uh, but yeah, if you have living force in competition with that for 200 years, then yeah, there's going to be the Maxwell or the Youngs, and there was even something that I read up on that they were testing, or the speed of light idea had come before Newton, like right before his time, like the 1650s, I think, is when they were trying to test the speed of light, like right after Galileo, I guess you could say, and that I think is the most perversive, dangerous, like active component in physics, just because a lot of people think that E, first of all, well, they think that energy is light squared, so that there's this wave particle duality, and that there is a like almost like a crosshatching between two waves of light particles. And yeah, I can see how that is just very dangerous to religious ideologies like aliens or things like that. Because when you turn to evolution, you see that yeah, it's an environmental case, but there's no proof that the environment is doing this, and then you can't really say anything uh, further other than like actually describe the notation of evolution and what evolution occurs and how evolution survives. So you can't really say that, well, we can have a that we can have conceptual power over evolution, even though we're not all evolutionists, we're not all atheists. So there's this uh, sort of like fine line between, I guess, how you talk about evolution. Whereas um, this whole, I mean, you could say it's in the same category as this physics argument because, yeah, if you open up another dimension, such as a living force or like this cross hatching of light particles over each other, or like, this uh, cross hatching of wave, it's a wave duality, a cross hatching like with a mass, then yeah, it gets, you know, it just really kooky. Um, and that's the whole idea. So the whole idea is to study this, everything that this, energy, dark energy, like, I don't know, it just is way out of focus. So this would have changed. Energy equals mass times the speed of light squared. We would have had living force equals mass times the speed of light squared. Um, was there any difference in that sentence? Mass times the speed of light. Okay, living force equals mass times. Okay, yeah. So they're saying it's the same thing, and I do agree. I didn't really think it was different at first, but I was definitely wrong about that because yeah, it doesn't make any notorial difference if like somebody's perception is center lodged in the idea that yeah, there is this like subatomic thing, and it kind of blew my mind that the subatomic theory or the atomic theory wasn't even really created until Einstein, and it was just all light before that. Everything was light, light, light. So, um, yeah, and we're talking about living force and the speed of light and all that, and then you have basically, in that order, you have like living force. You could have all this craziness, I think, with the double slit experiment. And then you have energy, and you have atoms, and you have uh, Schrodinger, and stuff like that, or many energy, atoms, many worlds, Schrodinger, sort of in that order. It just gets really dangerous. So yeah, obviously the fascination for energy was a little bit quicker than living force, but the fact that nobody is really observing living force unless it's to uh, sort of debunk actual force, then that's a problem. And it is kind of becoming alien theory where you're saying, oh yeah, we have to know that the environment is the cause of evolution, even though there's no proof. We have to believe in like some bullshit alien theory. And that's yeah, so that's kind of what it turns into. I mean, just through mechanics, the mechanics of living these diluted speed of light theories and such. So this would have changed our outlook of the universe and our place within it totally. I mean, why would there be any difference between saying something like energy equals momentum or, uh, instead of living force equals momentum? Um, I mean, projectionally, you could even say that living force does equal momentum because it's not this whole, well, the environment caused evolution. So if they're saying this whole duality thing, living force equals the cross hatching of wave particle light duality or energy, vice versa, then yeah, you have like the environment caused this uh, evolution to occur. But in terms of a physicalist idea or a physicist idea, then yeah, this isn't working. This metaphysics, well, it is kind of the beginning of metaphysics, maybe too, and I think that's intuitively true with like Kant's movement, like being kind of ontological. And then I think you have Schopenhauer right around the time of Charles Darwin. And yeah, you just have like sort of a big perverse melting pot of like this living force stuff, and then who can accept, and then uh, Darwinism gets sort of buried like living force did, even though people have been playing around with living force for a while. So people are still going along with evolution, but people can't convert to evolution until they have this idea that yeah, it's an impossible one-time event. And if and then if you start to explore the metaphysical position, you start to explore the ontological quantum mechanics of the universe, then yeah, you're going to have to derive your theory that it somehow evolved from life somehow evolved from the environment, which is not a very I mean, it's a very it's an impossible equation. So you have to get very kooky, and it's either aliens or gods. So um, or both, I suppose, which I think is the insanity of this experiment, and to entail that 1 billion years of evolution was was proposed by a consciousness. Yeah, that's sort of like the gridlocked mathematician. Like it's like this mathematized um, theory, which is like quantum mechanics and all that. And if you follow quantum mechanics, and you're good, even if you're good at quantum mechanics, and you can't help that you're good at it, then yeah, you have to like derive this idea that like if you don't look at quantum mechanics for what they are, then you have to have this idea that life um, could be like had to be derived from the environment. Like you can't just say, well, it's an impossible event that took place. You have to say, but the quantum mechanics says, uh, the living force was always here. The living force once was and always is, and all this, and that's basically the Leibniz. That's basically the Leibniz creationist argument. I mean, people who are still creationists in physics, I would say that that's how they're abusing energy in the living force. You don't much hear an atheist like Sean Carroll talk about energy because I feel like he understands that dilemma, like the Richard Dawkins dilemma, where you can't prove that evolution is caused by the environment. So you have to have like this. You have to say that genetics comes from evolution. Evolution, didn't come from the environment, sort of thing. And I think, um, a many worlds theory or something like that. I mean, even though it's proposed in this energy form, I mean, you can still understand that, yeah, there is a hijacking there. So anyway, um, this would have changed our outlook. It wouldn't have changed the outlook just because, yeah, living force. And I mean, he just says energy and living force are the exact same thing. Energy just took over and said it in a different way. It's like a three-dimensional cross-hatching of a wave particle duality. Except living force, obviously, is more of like it's like inverse square law. It's like inverse square law with an inverse circle principle or something. Like there is like an inverse square and then like a circle. And so yeah, I'm just saying that it's like this cross hatching wave particle duality theory, and then your mass is just infinite because of that cross-hashing wave-particle duality. You can say, as long as you have subatomics and things like that, I mean, it doesn't really matter. I mean, maybe it's just saying everything's made out of light. Maybe it's just saying everything's made out of electricity. But either way, a physical that's not a physical derision of uh, what we actually see and observe and things like that. So it's just an invisible universe. It just gets thrown into the invisible universe category, just like kinetic energy, because you're just talking about basically the inverse square law with uh, a little subset. The little subset is kinetic energy, and that's the living force that allows the inverse square law to, I guess, just um, realistically just backslide into all of this metaphysics and and ontology and God created us or aliens created us. So, um, living force equals mass times the speed of light. My cough is fucking awful. This would have changed our outlook of the universe and our place within it totally. I know, well, no, they're the same thing. Well, I guess they're just invisible universe theories. For with the belief in a creative force or vis viva comes the question that can be achieved. What are the possibilities and opportunities within creation? Obviously, atoms and etc. Atoms, etc. Atoms ad infinitum. So, yeah, I mean, it's a lot of juicy God. What is the force? Not the force from Star Wars, just this craziness. So, um, yeah, I mean, it's a pretty clear hijacking of what is perceptually um, accurate information, as opposed to um, just continuing to give God and aliens a chance. I mean, it's the same thing. So, but you kind of gotta say, well, I mean, that's how I guess pervasive, um, perverse the theory actually is. Um, this isn't even living force. There's barely any living force videos. I'd say at all. And there was one by you have the crash course Newton's laws. So Newton's laws is going to talk about force, but not living force. Yeah, it was this guy. All right, so I'm just implying too that work is sort of a subatomic word. It's sort of a subatomic living force energy word, just because if you just really think about it and you say, well, is it a part of our evolution? Like, did the work get us here? In a way, uh, it's sort of in connection with energy and like living force. So the living force is what started our evolution, or energy is what started our evolution. I mean, in that sense, I guess you could say anything really, but in terms of force, it seems like a little bit more planet. It seems like a little bit more consciously uh, vocalized than something like energy, something like work. I think work sort of falls in line with kinetic energy. That's all I'm really implying there.
Like work, energy, and force. In everyday parlance, they can mean a variety of things. But in physics, they have very specific definitions. So we will need to learn these definitions if we are to learn about classical mechanics. We already went over kinematics, which is the branch of mechanics that studies.
I mean, it's a little bit unfortunate they have to talk about classical, I think, as if Einstein is a classical mechanist, as if Einstein was really doing quantum mechanics. I mean, I'll just go on the record that's and say that, yeah, like living force really seems to get into quantum quantum mechanics just um, uncontrarily, like just like absolutely. So people talking about quantum mechanics maybe have to say, I mean, unless they explain themselves, that there is no, or even saying this, well, I don't know, is I guess like sort of a derivation, but an acceptable one. Like, okay, you can't prove that evolution started from the environment, so yeah, you don't know. Um, but I'd still say that many worlds is dangerous in that sense, or just being like a uh, information card for astronomy and cosmology and things like that. Like that's sort of useless. So that's in that would be like opposed to the way Tyson talks and things like that.
Studies the motion
People like that.
of objects without referring to forces. So now
So what is this like derivation? I mean, this dereliction, like the motion of objects without reference to forces, and then dynamics is okay. So they're saying dynamics is talking about these how we're connected through forces or something. I don't know.
Now it is time to learn about dynamics, which is the study of forces and their effect on motion. We will refer to a force as any interaction that, if unopposed, will alter the motion of an object. A force can cause an object with mass to start moving, stop moving, move faster, slower, or in a different direction. A person can
Right. So this is like sort of the quantum mechanic. I mean, sorry. The what do you say? The physical mechanic way to look at things, the push and pull, and yeah, in opposition to um, I don't know. There's just infinite subatomics,
exert force by pushing or pulling. An
or they say like the well, it open living force opens up a world of opportunities. Yeah, obviously.
object can exert force by falling or rolling. A planet or star can exert force through its gravitational pull. Any force must have both magnitude and direction, so forces will always be represented by vectors when we draw free body diagrams. If you push a shopping cart through the grocery store, you are applying force on the cart in order to generate a forward acceleration. This force vector, which begins at the center of the cart's mass, points in
Right. So I mean, this is what they now consider, I think, elementary physics, and they also try to imply that if they're using force, that is elementary physics, then they are implying that they are using Platonian theory, like they're using Aristotle theory and all that. They're using the Greek theory. So instead, they'll say like, well, in quantum mechanics we have many worlds, and that implies that there is a like this opportunity problem. So that's unfortunate. Or I guess they say, well, we have to use kinematics because there is a chance that we were genetically encoded by aliens. It's that crazy. So they won't believe in an invisible God, but they'll believe in physical aliens. Implied that they believe in evolution, but our evolution could have been started from the dinosaurs until now, or the bacterium until now, from the seafloor until now, through evolution. I mean, through evolution, but they have the key, and the key is, well, there's still a chance that it was from the environment, and that impossibility implies that it may have been something out of our thinking. So I mean, it completely divides itself from this evolutionary concept that you can't prove we evolved from the environment, which is just just a remarkable sale. I mean, it's a remarkable pitch.
in the forward direction. And
So if you do the forces, you're a Platonist. But if so long as you have like a little bit of living force in there, um, quantum mechanics can is the stock market is infinite. The amount your stock on quantum mechanics is going to go up. It will never stop. That's kind of like the idea. That's basically, that's a good way to put it. Like, as long as I invest in quantum mechanics, my stock in quantum mechanics will never, it'll always keep going up, right? So I just have to, like, all I have to do is buy out and get my money back on quantum mechanics. So if it fails, it fails. But so long as more people keep, getting into it, I can never go wrong because it is an opportunist theory. Whereas force obviously seems to have like a mechanical value. It has an obvious stopping point. Um, yeah, where quantum mechanics goes wrong, living force goes wrong.
also has a particular magnitude depending on how quickly you want to get your shopping done. And this magnitude will be represented by the length of the vector. Some forces are called contact forces because they arise when two objects touch or collide. Pushing a cart forward is an example of a contact force. The same goes for when you throw or kick a ball, go bowling, and even when you sit on a chair, pushing down on it with the force of your weight. Some forces are called non-contact forces. These involve some action at a distance, like objects that fall to the earth because of its gravity.
All right, so that's that right there. Non-contact forces, say it's derived from gravity, and then if you try to wormhole that gravity and try to jump in, you start with living forces, kinematics, and all this stuff. So it really is just kinematics and dynamics. That's what we're talking about here. So okay,
In classical physics, non-contact forces are sometimes called field forces because they typically involve some kind of a field, like a gravitational field or electromagnetic field. In fact, contact forces that describe macroscopic motion are just manifestations of field forces happening on the microscopic level. If you push an object, it moves because of the repulsion between the electrons in the atoms in your hand and the electrons in the atoms in the object. So even though we will discuss many different types of forces in this course, in actuality, there are only 4 fundamental ones.
all right. And now they're trying to create a fifth fundamental one. So you have strong nuclear, weak nuclear, electromagnetic, and gravity. So even this is a little bit, I guess, much, but just the derivation into atomics, which is interesting to keep it dynamical. But yeah, in terms of having, so they call it classical mechanics and quantum mechanics, right? Or classical mechanics. Is it classical mechanics and quantum mechanics? Yeah, I think it is. But so yeah, it's interesting that they have to deviate into something else.
Those are the strong nuclear force, the weak nuclear force,
Right. So strong nuclear force. I mean, we're talking about atoms here. So we talk about gravitation. More bits will pull in less bits. Less bits will be pulled into more bits. I mean, you could say they're also pushed. Um, Nuclear energy um, being pushed by the force. I mean, you don't have to have like, yeah, because I mean, how can you really exchange small bits being pulled by a large amount of bits? Okay, and how can you really say the only thing you'd be able to do is imagine something in between a small amount of bits and a large amount of bits to have your work or to have your what I'd say is kinetic energy. Well, maybe that's taking it too far, but You can't really imagine what's happening in the past, and that's kind of quantum mechanics. You can't really imagine, well, those bits are being pushed without, I'd say, much kinetic, without, I'd say, living force, so to speak. I don't know if that's too over the top. Um, but yeah, like describing that interaction that happens in between, again, like I'm talking about, like, um, what am I talking about? Yeah, I guess that's really, I mean, because there's always these like in between, uh, like this category of physics where something's happening in between the process of gravity. Like I was describing, like a meteorite going through the sky and how it's fire shielding against the atmosphere and things like that. That could be like an interaction between the big bits and the small bits, but then the meteorite is being pulled towards Earth through that gravity. So you have like three interactions there, and one of those, and then also, you're talking about, oh well, it came out of dark matter, so that's another subset of what you're talking about, and you can't really say, well, there was force here, force there, force. I mean, you probably could in a way, like all those forces could just make up that one. Like the strong nuclear force is the meteorite, the weak one is the atmosphere, the electromagnetic force um, is what's happening behind uh, the meteorite, and gravity is the precipitation of the meteorite being pulled into the atmosphere. So you could just say that. I mean, really. And then in this sense, they're trying to create this fifth fundamental force. I mean, that's like the dark matter component, I think. But like you could just take care of that with electromagnetic force. It seems like.
Force, the electromagnetic force, and gravity. All other forces are just some variation or application of one of these four, which we will get to a bit later. Given that any force must have magnitude, we must have a unit of measurement to communicate these quantities. That unit is called the Newton, and it is equal to the amount of force.
Right. So this is where it's gonna be a little bit much, but yeah, at least it is. At least it is theoretically possible or theoretically sound, all that. But yeah, in terms of what quantum mechanics does and how it says, well, we're going to calculate, this, that, and the other um, to the nth degree. Yeah, that's pretty insane. Because there really is no point in opening up that door to saying that, yeah, we evolved from the environment, because you're not going to be able to prove it. And then if you use this living force to do that, that's what you kind of open up to, which is insane. The way our society has ran like that. And just the whole thing with like how, oh, well, there's the male and the female, and the males are utilizing, I don't know, their whole thinking thing more because they are sexualizing more, and the women are sexualizing less, so they always feel intrepid with the males or a philosophical standing, and they can't say, well, yeah, I mean, they can't say something like, well, the force is a more applicable thing than living force or quantum mechanics, just because, yeah, it's like this whole, you know, kind of opportune thing. Like, well, I mean, if the opportunity happens, then the male is probably going to, wreck me, since I'm just like a baby maker and things like that. In that sense, yeah, force is a much more applicable thing, where quantum mechanics is just this overriding subject that leads to all these sort of like insane thoughts. It doesn't really have. I mean, it's peaked. I mean, it peaked, as soon as like it was thought up. So yeah, I mean, just to talk about like the sensicality of like males and females and how they're able to philosophize things. Um, quantum mechanics, yeah, it could have been thought up just because like, or it can be attractive just because, yeah, it's well, opportunity is everywhere, so, or like, I'm going to get 70 virgins in heaven, that type of thing. Where if you just have one concrete physical force and you go back to evolution, you say, yeah, I can't prove the environment was what caused evolution, but this is evolution. And evolution makes sense because of just the overriding data of paleontology, anthropology, geology, things like that. So,
that will cause
and science can help with that, but yet, if that wasn't enough, then living force, quantum mechanics, all that can help you understand, the universe and its proportions and how the universe is identical to the Earth, and we're all identical uh, microscopic bits of the universe, like just crazy shit. But yeah, if Newton's worked, then yeah, like I'd use Newton's, but I don't think Newton's are measurable in light, and they just love measuring their light bits so much. So.
a 1 kilogram mass to accelerate by 1 meter per second squared. Since these are all SI units, the Newton is the SI unit of force. The Newton is named after Sir Isaac Newton, who put forth the first extensive study of forces in the 17th century. His studies are summarized in the Principia, where he describes the laws of motion that deal with force and mass. These laws changed the world and are considered among the most important accomplishments.
Yeah, but they don't make it doesn't matter. If they just violate all the laws using kinetic energy. Well, again, kinetic energy is an infinite math, and really the first math because you have like these infinity problems, and so it doesn't matter. If you have a law, and there's an infinite amount of ways to get around that law. Like if the law, um, it's almost like it's like the law is to have sex. The law is to eat food. The law is to um, grow old. And those are like the laws of the universe. Well, you have an infinite amount of ways